Okay. Admit all. ओके, मेरी आवाज आ रही है?
हाँ सर।
तो शैल आई कंटिन्यू? चलो मैं बोर्ड को शेयर करता हूँ और शुरुआत में तुम कैमरा ऑन किया करो जरूर। क्यों नहीं हो रहा है? Okay, so far what we have found now sequences xn inside M and sequences. What do I have? Okay,
Y and N.
I have found another, and they are mutually orthogonal. Okay, every xn is orthogonal to every yn and vice versa. So once we are there, so by Pythagoras theorem, now I've got Zn minus Zm square can be written as xn plus yn minus xm plus ym square, but this is the same thing as, because vector addition is commutative, it's an additive abelian group, I can write it as xn minus xm plus yn minus ym, and of course ये जो xn minus xm है ये m के अंदर है, because ये दोनों यहाँ वहाँ है पूरी की पूरी सीक्वेंस, तो उसके दो मेंबर्स का डिफरेंस भी उसी में होगा क्योंकि वो सब स्पेस है और ये n में बिलोंग करता है, ये म्यूचुअली, और ये वेक्टर इस वेक्टर के साथ ऑर्थोगोनल है, so this is the same as xn minus xm का स्क्वायर plus norm of yn minus ym का स्क्वायर, and you have to remember that Zn जो है, it's a convergent sequence, right? This is a convergent sequence, therefore it's a Cauchy sequence. Now since Zn is convergent, implies that Zn is Cauchy. So this thing would approach 0 as nm approach. Zn is Cauchy, and which implies that xn and yn are Cauchy sequences. क्योंकि अगर ये अप्रोच करेगा 0 तो ये भी करेगा ना, because if left hand side is 0, right hand side is 0 as nm becomes very very large. अगर ये Cauchy sequences हैं, and since H is complete, it's a Hilbert space, it implies that xn converges to some x belonging to H and yn converges to some y belonging to H, but m and n are closed, और ये जो sequences हैं ये वहाँ belong करती है, so therefore m and n must contain all the limit points, therefore all the limits of the sequences that they contain, so which implies that x must belong to m and y must belong to n. तो हमारा एक हिस्सा हो गया. Now z is equal to limit, it is the limit of Zn, but this can be written as limit n approaches infinity, xn plus yn obviously, लेकिन xn का जो लिमिट है, because limit can distribute over addition, because addition is continuous in vector spaces, normal inner spaces, और हमने माना है कि इसका जो है x है, इसका y है, so therefore z is equal to x plus y, where x belongs to m and y belongs to n, which implies that z belongs to m plus n, so which implies that m plus n is a closed subspace of H. So ये हमारा एक और स्टेप हो गया. इसकी तरफ बढ़ने में okay. What we do is the last one theorem, जो ना प्रोजेक्शन थ्योरम होगा, लेकिन वो इन सब को यूज करेगा जो हमारा चेन ऑफ सीक्वेंस, चेन ऑफ जो हमारा आर्गुमेंट है उसको फाइनली पहुंचाएगा उस तक. If M is a closed subspace of a Hilbert space H, then H can be always written as M direct sum M perp. ठीक है? Proof. Now, since M and M perp are closed, so M perp is always closed. This is by supposition. Closed subspaces of H by previous theorem. इनका सम जो है M plus M perp is a closed subspace of H. तो हमें दिखाना है लेकिन ये H के बराबर है ना? We show that first हम ये दिखाएंगे M plus M perp जो है वो पूरा H है. Assume to the contrary. Assume to the contrary. मान लो ऐसा नहीं है. Then there exists a non-zero Z naught belonging to जो ना पहला वाला हमारा थ्योरम था, because ये proper subspace होगी such that Z naught is orthogonal to M plus M perp because it's a closed subspace, a proper subspace. अगर ये proper subspace होगी, so there would be something. ये हमने जो दूसरा या तीसरा थ्योरम जो इसमें किया था इस सीक्वेंस में, तो ऐसा होगा. ठीक है ना? Then Z naught must belong to M perp intersection M double perp. ये हम जरा यहाँ पे करेंगे अपने, because Z naught is orthogonal to x plus y, any vector of this type where x belongs to M and y belongs to M perp. What does that mean? It implies that Z naught x plus y जो है वो 0 है for all x belonging to M and y belonging to M perp. So that's the meaning. Z naught is orthogonal to, मतलब अगर Z naught ये है तो फिर ये उसका conclusion है, which implies that using the property of the inner products that it distributes over the sum, यानी ऐसा होना चाहिए. Now this is true for all x, y, नहीं sorry, x belonging to M and y belonging to M perp. अब x M में है, अगर ये सभी x के लिए true है, तो in particular taking x equal to 0 because 0 belongs to M. तो अगर मैं x को 0 लूंगा, it means Z naught y is equal to 0 for all y belonging to M perp, and taking y equal to 0, you will get Z naught x is equal to 0 for all x belonging to M. तो इसका मतलब इससे हमें मिला Z naught must then belong to M perp का perp, और इससे हमें मिला then Z naught belongs to M perp. It means that Z naught belongs to their intersection, right? But this is impossible. Why? Why is that impossible? A vector cannot be non-zero and belong to the subset and its perp, क्योंकि इसको खुद के साथ फिर ऑर्थोगोनल होना पड़ेगा, और खुद के साथ सिर्फ 0 ऑर्थोगोनल है, और हमने कहा है 0 Z is not equal to 0. Hence H is equal to m plus m perp. बट हमें ऑलरेडी पता है m इंटरसेक्शन m perp जो है वो 0 है. Then it implies that this representation is unique. और unique का मतलब हम इसको ऐसे लिख सकते हैं. And we are done. तो इसका एक रिमार्क है, we can always define a projection. है ना? Projection theorem इससे हमें मिलेगा. So remark, we can, if M is a closed subspace, then M is of a Hilbert space H. Then M is complemented in H. वही हमने ऊपर भी लिखा, लेकिन complemented in H का मतलब now there exists a P that is a projection from H to M such that P is linear onto continuous and P composition P is equal to P. वो तुम आराम से कर सकते हो because H can be written as M plus M perp. So you define P of Z to be, which is the same thing as P of X plus Y. हम इसको लिख देते हैं X, where Z is equal to X plus Y is the unique representation of Z as sum of vectors in M and M perp. Now it's easy to see that what then P is linear. Now P is linear and onto, of course, because of this thing. And of course it is continuous because norm of PZ का square would be equal to norm of Y square. मैंने Y लिखा यहाँ पे, मैंने Y लिखा, X होना चाहिए, है ना? Norm of X square, which is less than or equal to norm of X square plus norm of Y square, which is the same thing as norm of X plus Y का square because they are mutually orthogonal, which is equal to norm of Z square. That is P of Z is less than or equal to norm of Z, तो ये continuous है. It's a bounded linear operator. Furthermore, of course projection है because P of Z is equal to P of X, which is equal to X, which is equal to P of Z. So for all Z belonging to H, which means P composition P. So every closed subspace of a Hilbert space is complemented. हमने इससे पहले देखा every closed subspace of Banach space is complemented. ये लेकिन ये उसका थोड़ा special case है क्योंकि ये है ना, it's like M plus M perp. It's not like M plus N. वहाँ पे हमें N का कुछ नहीं पता. यहाँ पे पता है कि M का और आपस में connection क्या है ना? हाँ. ये उसका एक special case है because Hilbert spaces are special Banach spaces. ऐसी Banach spaces जिनमें जो norm है वो inner product से मिलता है. So let's leave it there. कल हम आगे बढ़ेंगे और चीजों की तरफ, ऑर्थोगोनैलिटी को फर्दर करेंगे हम. आज के लिए इतना ही है, इसको खत्म करते हैं. कितने आए हुए हैं? 24.